Can you store the sun? It sounds impossible, capturing a star, trapping its fire, and saving it for another day. But every second, our planet is drenched in sunlight, enough energy to power human civilization thousands of times over. The challenge isn't catching it. It's keeping it. Let's rewind about 100,000 years. Deep inside the sun, a photon is born, a tiny packet of light, forged in the nuclear heart of our star. It bounces around endlessly, ricocheting off atoms for millennia before finally escaping into space. And after a journey of 8 minutes across 150 million kilometers, it lands right here on Earth. We can use that sunlight instantly. A solar panel captures it, freeing electrons and creating an electric current. That current can charge your phone, light your home, or boil your morning kettle, all thanks to a photon that began its journey before humans even existed. But here's the problem. When night falls, the sun's gone. And so is its power. To truly live off sunlight, we must find a way to store it. One way is by turning sunlight into heat. Giant fields of mirrors focus light onto a tower filled with molten salt, a material that can stay hot for hours after sunset. The heat is used to boil water, spin turbines, and generate electricity, even at night. It's brilliant, clean, and proven. But molten salt can only store energy for about half a day. If clouds linger, or winter stretches on, we're still left in the dark. The next step is to use sunlight to make electricity, and store it directly in batteries. Lithium-ion batteries already power your phone and electric car. But now, entire cities are experimenting with battery farms that can keep neighborhoods running for hours, even days. Researchers are tweaking materials from sodium to iron to vanadium, searching for the perfect mix of cost, capacity, and stability. Yet, no battery can hold enough energy to bridge months of dark winters. So, scientists began to think beyond batteries, beyond storage. What if, instead of storing sunlight as electricity, we turned it into a fuel? Run an electric current through water, and it splits into hydrogen and oxygen. Hydrogen gas burns clean, no carbon, just water vapor. It can power factories, airplanes, and even ships. But there's a catch. Hydrogen is incredibly light, and storing it as a liquid requires freezing it to -253 degrees Celsius. That's colder than deep space itself. Keeping it that cold takes energy, and suddenly, our stored sunshine begins to leak away. So, scientists got clever. What if we added nitrogen, the gas that already makes up most of our air? Combine hydrogen with nitrogen, and you get ammonia, a simple liquid that's far easier to store and transport. It can be shipped in tankers, stored in barrels, even piped across countries. Later, we can split it again to get the hydrogen back out, or burn the ammonia itself as a clean fuel. In these forms, the energy of the sun can be bottled, moved around the planet, and released whenever and wherever we need it. It's not just solar power anymore. It's solar fuel. From molten salts to metal batteries. From hydrogen to ammonia, each step brings us closer to something extraordinary. A world powered entirely by the star we orbit. Imagine a winter city glowing on energy captured in summer sunlight. Ships crossing oceans on fuel made from the sky. Factories running on light that left the sun years ago. This isn't science fiction. It's already happening, quietly, experimentally, in labs and pilot plants around the world. We may not be able to hold the sun, but for the first time in human history, we're learning how to store its fire. A real, tangible bottle of sunshine.